At the Flom Eye Institute, we have developed a rather unique environmental chamber which enables us to control specifically temperature, humidity, and airflow, and vary them to all sorts of degrees. We can then evaluate individuals who have dry eye or a variety of ocular surface diseases, and we can emulate almost any kind of environmental condition. We have deployed specific, unique technology in this chamber, which no one else in the world has, which enables us to determine and to study variations in the tear film that fluctuates on the surface of the eye. The tear breakup will, of course, affect the visual acuity, and we can translate that into a reading, not that I see blurry or I see well, but we can translate that into 20/40, 20/25, 20/70, or 20/60. And we can get that reading, many times during the course of a second. So we deploy OCT technology, not the basic OCT technology which you see, where you get an image of the optic nerve or an image of the macula or anterior chamber OCT, but we have constructed a specific OCT instrument for the ocular surface, one that has a very high resolution capability, so that we have less than 1 micron ability to resolve. And that is important because that enables us to get the ocular surface tear film over the surface of the eye and measure its thickness, and at the same time measure the superior and inferior meniscus. And this is the only unit in existence that enables that degree of sophistication, if you will. And the same kind of thing goes with our wavefront analysis. Now, as you know, wavefront analysis has been used for refractive surgery, and in fact the adaptive optics that it's based upon was developed by David Williams at the University of Rochester as well. We have constructed a wavefront sensor specifically designed for the ocular surface, and this enables us to be very, very sophisticated in measuring the tear film breakup time, and not only the actual time at which it breaks up, but we think we can tell you and speculate upon where it's going to break up and when it's going to break up. Dr. Zavislan from the Institute of Optics has been working with us for a number of years, and he has developed a technology which was taken from metallurgy, and so the engineering science involved in metallurgy. And what this does, and he has termed it ellipsometry, and ellipsometry enables us to reflect light from the surface of the cornea and the tear film. And light has various properties. It has intensity, it has color, and has reflective capability. And by reflecting this light and then polarizing the light, we get two images at 90 degrees different polarization states. And then, of course, we have the technology which is based on thermal imaging. And while thermal imaging is available in the Defense Department and the military uses thermal imaging and it's being used throughout industry, we have modified both with hardware and with software the capability of scanning the eye during the course of a blink cycle. And then post-production, after that information is all settled, we can then, with our software, query the system to give us the specific readout of temperature variations that occurred over any specific point on the corneal surface. We're increasing our database of potential subjects. We now have enrolled in our database upwards of 500 individuals who have been approved and who have volunteered to come in as subjects for our research.